بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the last section in chapter 6, section 6.5, and it's about average value of a function. You know, if I say to you, what is the average of 4 and 5? You know how to find the average of two numbers. You add 4 plus 5 over 2. So the average is 4.5. Now here, if you have finite numbers, you add them and find the average and divide by the number of elements you have. But what about if we talk about the average value of a function? Well, a function f will have infinitely many values in an interval from a to b. So this is a function f. And if I ask you to find f of a, this is f of a. So this height is f of a. This height is f of b. A plus 0.000 would be there. So there are a lot of values, infinitely many values here of the function. Infinitely many heights, y values. And the question, what is the average height? What is the average height of the function? Okay. This is called the average value of the function. Well, this is the definition. We find the integral, the definite integral of the function. And this will give us what? Will give us the area. The area below the curve, y equals f of x. This area, all of this area, which is dashed here, and colored, this colored area, all of this area. And we divide this area by b minus a, the length of the interval. So if we divide the colored area, blue, with b minus a, so this area over b minus a, we get the average value. So this is the definition of the average value of a function. For example, find the average value of this function on this interval. So this is a and this is b. And if average would be, using the definition, 1 over b is 2, a is -1, integral from -1 to 2, f of x. Where is f of x? It's given in the question, 1 plus x squared dx. That's it. This will give you the average height or the average value of this function. It's equal to 1 over 3. And how to find this integral? Well, the integral of 1 is x. The integral of x squared is x to the power 3 over 3. And this is a definite integral, so we have to evaluate this from -1 to 2. So it is 1 over 3. Replace x by 2, so it's 2 plus 4 over 3 minus, replace x by -1, -1 minus 1 over 3. If you evaluate this using the calculator, you will have 10 over 3 minus, so plus 4 over 3, yeah. Well, okay, 10 over 3 minus 1 minus 1 over 3. This is 2 to the power 3. This is 8, not 4. So this is, I have a mistake. Minus -4 over 3, 6 over 3. The answer is 2. So the average value of the function is 2. What does it mean? This is the average height. So let us try to understand and graph this function. 1 plus x squared, the graph is a parabola 1 unit up. So at 0 it is 1, at -1 it is 2, at 1 it is 2, and at 2 it is 5. So this is the graph of the parabola in this interval. And we found that we divided the area below here, this area below the curve, over b minus a, okay? And we found that the average height is 2. So it says that this height up to 2 is the average height. So we have height 5, f of 2 is 5. We have height 1, and the average height of this function is 2. So that's what we mean by the average value of a function. Now the second theorem in this section is the mean value theorem for integrals. And it says that if f is continuous, if the function is continuous on the interval ab, so for example, this function 1 plus x squared is continuous in this interval from -1 to 2, then there must be a number c in the interval ab between -1 and 2, such that f of c is equal to the average value of the function. So we found here that the average value is 2 in this example. The average value is 2. So there must be a number here c between -1 and 2 included, -1 and 2 included, such that f of this number would be 2. You can notice here, you can see here in the graph that we have f of -1 equals 2, and actually f of 1 is also 2. So c guaranteed by the number c guaranteed by the mean value theorem. In this example, we have 2 values of c, plus or minus 1. So that's what the mean value theorem says. It says that the average value of the function is one of the values, okay? There is c such that f of c would be equal to the average value. So the average value is one of the values of the functions, of the function. Notice here, 4.5 is not a number, but is not a number in the data. We have 4 and 5. The average 4.5, which is not one of them. But here, the average value, according to the mean value theorem, would be one of the values of the function, because there is c such that f of c equals f average. And for example, here, 2 is one of the values. It appears when c is 1 and -1. So this is the mean value theorem. It also means that if you find this area, the area of this region, because 2 is the average value, so if we find the area of this region, it would be equal to the area below the definites, below the function. Okay, so it would be equal to f of c, that's here if you multiply by b minus a. So this area, which is below the curve, is equal to f of c, which is in our question 2 times b minus a. So the area of this rectangle, the green rectangle, would be equal to the area below the curve. Some exercises. So these are the only 2 theorems, 2 ideas in this section. Find the average value of f on the given interval. So f average equals 1 over b minus a integral from a to b f of t dt. And we need to solve to find this integral. We write it t to the power -2, and the integral would be t to the power -1 over -1 from 1 to 3. This negative will be -half, and t minus 1, I write it 1 over t from 1 to 3. So 1 over 3 minus 1 over 1. This is -2 over 3 times -half. It would be 1 over 3. So the average value of this function in this interval is 1 over 3. This is part A. Part B, find C in the given interval such that f average equals f of C. This C is the number guaranteed by the mean value theorem. So f of C, we are searching for this C. We need to find C such that f of C equals f average, which is in this example 1 over 3. So we need to find C in which f of C equals 1 over 3. But what is f of C? Well, we have f of t is 1 over t squared. So to find f of c, I replace t by c. So I have 1 over c squared equals 1 over 3. And solving this equation will give you c. 1 equals to 1, so c squared equals to 3. And c is positive or negative square root of 3. But negative square root of 3 does not belong to the interval 1 and 3. So C, guaranteed by the mean value theorem, is square root of 3, which is approximately 1.7, belongs to the interval. So this is the C. This is the answer of part B. Another example, another function. Let us find f average. F average is 1 over 2 minus 0, b minus a, integral from 0 to 2, f of x dx. How to find this integral? Well, if you take u equals x plus 1, then du would be dx. And if x is 0, u is 0 plus 1, 1. And if x is 2, u is 2 plus 1, which is 3. So this integral would be integral from 1 to 3 instead of 0 to x plus 1 is u, dx is du. The integral of u to the power 3 is u to the power 4 over 4 from 1 to 3. So I have 1 over 8, 2 times 4. And u to the power 4, replace it by 3. So 3 to the power 4, which is 81. 1 to the power 4 is 1. So 80 over 8, that's 10. So the average value of this function in this interval is 10. Part B, find C, such that f of C equals f average, which is 10. So what is f of C? This is the function. Here, the function is g. So we can say that this is g average. And also g of c equals 10. So g of x equals x plus 1 cube. What would be g of c? We replace x by c. So I have c plus 1 to the power 3 equals to 10. And now solving this equation will give you the value of c. So to solve this equation, I take the cube root of both sides, and then I take -1 to the other side, and this would be c. Let me check that c is indeed in the interval from 0 to 2, So if you evaluate this by calculator, this is approximately 1.15. It belongs to 0 and 2. So everything is fine. Of course, we have to check that C belongs to 0 and 2, okay? The original numbers here. 1 and 3 when we deal with U, not with X. Okay, some other questions here about the average value of the function. Find the average value of the function on the given interval. So the formula says if average equals 1 over 4 minus 1, which is 3, in, integral from 1 to 4, e to the power 1 over z over z square dz. Well, how to evaluate this integral? I take u equals 1 over z. This is by substitution. Why? Because du, the derivative of 1 over z, is negative 1 over z square dz. You can check this derivative. So if z is 1, 1 is the value of z, what would be u? 1 over z, 1 over 1, which is 1. And if z is 4, u would be 1 over z or 1 over 4. So this would be equal to 1 over 3 integral from, instead of 1, I have 1. And instead of 4, I have 1 over 4. E to the power 1 over z. Well, here I have du equals negative 1 over z square. So I need a negative sign. So I'll put a negative sign here and a negative sign outside. So I'll have a negative sign here. And now e to the power 1 over z would be e to the power u, because 1 over z is u. And negative 1 over z squared dz is just du. The integral of eu is eu from 1 to 1 over 4. So it's negative 1 over 3 times e to the power 1 over 4 minus e to the power 1 or e. And this is the average value of the function, the average height in this interval. G average 1 over 2 minus 0, integral from 0 to 2, 9 over 1 plus t squared dt. This 9 is a number, I'll take it out. And the integral of 1 over 1 plus t squared, if you remember, is tan inverse of t from 0 to 2. So the answer is 9 over 2 tan inverse 2 minus tan inverse 0. But tan inverse 0 is 0. So the answer is 9 over 2 times tan inverse 2. This is the average value of this function. If average here, 1 over 1 minus minus 1, so it's 1 plus 1, which is 2, integral from negative 1 to 1, x squared over x cubed plus 3 to the power 2 dx. How to evaluate this integral? I take u x cubed plus 3y, because du is 3x squared dx. If you have any problems, please, here with integral by substitution, just go and refresh your mind and see the video about substitution. So I must have 3 here. So I put it here and I multiply by 1 over 3 outside. And I need to change the x values to u values. So if x is negative 1, u would be -1 plus 3, u would be 2. And if x is 1, 1 to the power 3 plus 3, so u would be 4. So if average would be equal to 1 over 2 times 1 over 3 is 1 over 6, and -1 will correspond to 2, and 1 corresponds to 4, 3x squared dx is du, x cubed plus 3 is u, and there is a 2 here. So how to find the integral of 1 over u squared? I take it up u to the power -2, and the integral is u to the power -2 plus 1, or u to the power -1 over -1 from 2 to 4. This negative, I'll take it here, so I have -1 over 6, and u to the power -1, I will write it 1 over u from 2 to 4. So -1 over 6, 1 over 4 minus 1 over 2, which is -1 over 4. So -1 over 4 times -1 over 6 will give you 1 over 24. So that's the average value. The last question, H average, would be 1 over pi minus 0 from 0 to pi cosine 4x times sine x dx. Well, to evaluate this integral, I take u equals cosine x, because the derivative of u du is negative sine x dx. Derivative of cosine is negative sine. So I need a negative sign here. So I put negative here and negative here. And I need to change these values from x values to u values. So if x is 0, u would be cosine 0, which is 1. And if x is pi, u would be cosine pi, which is -1. So this would be -1 over pi times 0 will be 1, pi would be -1. It's okay, the integral from 1 to -1, that's okay. If you want to make it from, I'll do it now. But let me continue. Cosine is u, so I have u to the power 4. Negative sine dx would be du. So this would be my integral. Remember, if you remember, one of the properties of the definite integral, I can change these limits and multiply by a negative sign outside. So there is a negative sign already. So this would be 1 over pi from -1 to 1, u to the power 4 du. You can continue without doing this, but I did it. Okay, that's it. So y to the power 4 integral would be y to the power 5 over 5 from -1 to 1. So this would be 1 over 5 pi, because I have 5 times pi, and 1 to the power 5 is 1, minus 1 to the power 5 is -1. So 1 plus 1 would be 2, and the answer would be 2 over 5 pi. Hope you enjoyed the average value of a function, and see you in another video.